Hello students, this is part 2 of chapter 3 and we're going to go into naming alkanes, and I also want to take you through naming alkenes because you'll need that for some upcoming work with your lab. So focus on the proper IUPAC naming, and then when we name alkenes, notice that there are geometry differences, and we're going to talk about cis-trans and EZ. So when you name alkanes, you always have this systematic name you can give it. It's based on the IUPAC system. And just to let you know, there are also some common names that sometimes you'll see. Definitely you can use some common names, but if I ask you for the IUPAC name, you do need to give that to me. This is the method. First of all, you want to specify where, based on numbering, where a certain group is located. Then you'd use a prefix to say how many substituents there are and what substituent you have, for example, methyl or dimethyl or trimethyl. Then you put the main parent, the longest chain. This could be hex or bute for butane. The suffix can vary depending if you have an alkene or alkyne or alkane. So that could be hexine, for example. Okay, let's look at this example. If I give you the structure, the first thing you need to do is identify the longest chain. Don't just go left to right, because going left to right, you would have counted 6 carbons. If you go left to right and go down, there are 2 more down here, so that's the longest chain, 7 in a row. But should you number from left to right or right to left? It depends. You want to number so that you're closest to the nearest branch point of a substituent. The reason is that it gives the substituent the lowest possible number. So if I number down here 1, 2, 3, it gives this methyl substituent a 3 number. If I went the other way, 1, 2, 3, 4, 5, it would have given it 5. So we name this, and I highly recommend numbering the chain, circling the groups. That'll help you. So your longest chain is 7, that's het. There are no double or triple bonds, or there's no alcohol, so it's heptane. And then there's a methyl group at the 3 positions, so 3-methylheptane. Notice all one word, you use a dash between letters and numbers. We're going to do this one and walk through again the rules. Find the longest continuous chain. So I could have gone left to right, and that would have given me 8 here. If I went down here, that's a shorter chain. If I go left to right, I'm closer to the first branch point, so that's the lower numbering for the substituent. So that's better than right to left. So this is correct numbering. Then identified you have a methyl and an ethyl group. So we already did rules 1 and 2. Next, you're identifying the substituents. If there are 2 substituents on the same carbon, meaning if there was a methyl here and another methyl instead of this H, you would use a prefix dimethyl. And you would have given them the same number. So even though you write dimethyl, you don't know where those 2 methyls are. One could have been on 3, one could have been on 8. You would have had to have said 3,3-dimethyl. But in this case, there's only 1 methyl, so it's just 3-methyl. Next, you list the substituents alphabetically. Let me tell you something. Prefixes are ignored. However, 2 prefixes are not ignored. You count iso and cyclo in alphabetizing. So let's do this. We have 3-methyl and a 5-ethyl, but ethyl, E comes before M. So even though the number's higher, you write it in alphabetical order, 5-ethyl 3-methyl octane. Also, if you have a really complex substituent, you can name it as a compound, as if it were a compound itself, and you can use a common name. For example, sect-butyl, you could do that, like 5-sect-butyl. We're going to practice. Don't be tempted to number left to right, and always look for the longest chain and start numbering nearest the first branch point. Pause this and practice number 1 first. And I'll go through it and then pause again and do the rest. Okay, so here, what's the longest chain? There are 2 groups here, there are 2 groups here. So just going across actually is fine. So in this case, I can just go across and I have 6 in a row. That's my longest chain. But my nearest branch point is here on the right side. So I'll start numbering from the right. 1, 2, 3, 4, 5, 6. I have hexane and I have 2 methyls here. So I need a 2,2 dimethyl, but I also have a 4-ethyl. E comes before M, so I write 4-ethyl, 2,2 dimethyl hexane. Notice dashes between numbers and letters, but between numbers, it's just a comma. Let's do the next one. The longest chain is here or all the way across. If there are 2 longest chains, pick the one with the most substituents. The reason is it simplifies the naming of the substituents. So I'm going to pick this 1, 2, 3 because it's nearest the branch point versus starting 1 here. I have octane as my longest chain. I have an ethyl at the 3 position alphabetically, that'll come first. And then I have 3 methyl. So I'm going to have a trimethyl, and I just use the numbers 2, 4, 5 trimethyl. So here's your full name. Let's do number 3. My longest chain is 6, numbering from the right. And this is quite a simple one. There's a methyl group at the 2 and the 3 position. So just 2, 3 dimethyl hexane. And this last one, take your time. I'm going to number right to left because my nearest branch point is here at 3. And I've got a couple groups. I've got a methyl, I've got an ethyl. We've dealt with those. This group, though, is what? The easiest way to name this is just its common name, isopropyl. And so the I does count. Iso and cyclo count for alphabetizing. So the E, 5-ethyl comes first, 4 isopropyl, 3 methyl, octane. Let's now name alkenes. Exact same, very similar type of ruling, but you use ENE to identify the alkene functional group. If there's more than 1 double bond, use diene, triene, etc. This is where it's different. You number the substituents as usual, but you begin at the end nearest the double bond. So it's not necessarily nearest the closest branching. If it's the same, then go ahead for the closest branching. Let's just do some examples. In a ring, you always start the alkene at the 1 position and then number it so that the substituents get the lowest possible number. Examples help here. So let's do this one on the left. 4 carbons, so we're going to have bute. 2 double bonds, so you can do a diene. And what else? How do I know if I name from the left or the right? Alkenes start at both ends, so I'll number from the left nearest this branch. So I have a 2-methyl, so I just write 2-methyl, and I have to identify where the double bonds are. And you identify it by the number where the double bond starts. So this double bond starts at 1 and ends at 2. So it starts at 1, and then another one starts at 3. So I could write 2-methyl, 1,3-butadiene. If you want, you can also put that number for the double bonds right before the ene part. So you can also name this 2-methyl-buta-1,3-diene. Both are correct. It's your preference. Both would be correct on an exam. Here we have a cyclopentane, and it's not a pentane, it's a pentene because it's a double bond. And so a 1 position will be here to just give the lowest numbering. 1 bromo, we would put a 2 here, a 3 here, 3,3-dimethyl, cyclopentene. We have a whole section on cycloalkene and alkane naming, so don't worry too much about details right now. I mentioned there are geometry differences for alkenes, and the reason is a double bond can have substituents on one side of the double bond or on opposite sides. So notice, I'm talking about a double bond with 2 carbons and a substituent on each of those separate carbons. If you draw an imaginary line along the double bond, those substituents can be on the same side here. We call that cis for the same side. And so this is just a 1, 2, 3, 4 bute, double bond ene, so butene, but where is that double bond? In the 1, 2 position, it starts at 2. So this is a cis 2-butene. Notice I don't say dimethyl because I captured that in the longest chain. Here, when they're on opposite sides, this is trans 2-butene. The reason why these are 2 separate compounds is because this pi bond has no free rotation. You'd have to break the pi bond, rotate to change that geometry. Can this one on the bottom be cis or trans? Nope, because no matter how you rotate it, flip it, you come back to the same compound, and cis or trans is describing substituents on the 2 separate adjacent carbons. So this last slide here involves tri or tetrasubstituted alkenes. This is a little annoying. When you have tri or tetrasubstituted alkenes, you change from using cis-trans to E or Z. And E is kind of like trans. E is entigen, meaning opposite in German. Z is zusammen, meaning together in German. So Z, in your head, think it's like cis. E is like trans. And we're going to learn some sort of naming rule, and it's assigning priority, mostly in chapter 5, but I'm just going to give you a preview here to be able to do this. When you assign cis or trans, you look for the highest priority groups. I'm sorry, for cis or trans. But when there are 3 or more substituents, you have to prioritize them. So here, if I'm looking at the group on the left, that's bromine, that's the highest priority over H. But here on the right, should I look at it versus methyl or chlorine? You pick the one that has the highest atomic number. So chlorine has a higher atomic number than carbon. So this is a higher priority group. And compared to bromine, you see, are they on opposite sides or the same side? Opposite. So that's like trans or E. So we name this E in parentheses to start, and then you name the molecule as usual. 3 carbon chain is prop, propene, 1 propene, and there's a bromine at the 1 position, and then a chlorine at the 2. So this is your full name. This one is the same naming, but just Z. Okay, that ends the naming section, and we'll continue more next time.